So we look at chapter 1, and it's basically fundamentals of electricity, which you guys have seen probably a number of times. But again, I want to go back. You know, the basic rule is we're going to control electrons. They're free in nature. They just do whatever they want. Um, and let's talk a minute about the physics of it. Carol probably talked to you about this, but when you look at the periodic table and you look at everything in the periodic table, which part of the periodic table is more conducive to electron transfer? Which elements?
Gold and the ones with lower valence electrons.
Okay, and in the table, where do they tend to be? In the middle, to the sides? If you look at the table, the middle ones are pretty stable. What does that mean? Stable. Stable.
Better conductors?
They're not
likely to jump.
not likely to lose or gain electrons, right? In a chemical reaction or in physical conduction. What's that?
You grab these?
I didn't grab them.
How'd they get up there?
I don't know. I didn't bring them. It's a mystery, Dick. Okay, so the electrons, let's think of something that has really stable electrons. Plastic's pretty stable because it's an insulator. So why is it stable?
Charges are balanced in electrons.
Okay, so the molecule wants to hold its electrons in orbit, right? And it says to that last orbit, it says, you're not going nowhere. I want you right here. So they are balanced, but all of them are pretty balanced. It's just whether or not it wants to hold on to that electron or not, okay? So in the middle, we see pretty much hold on to the electrons. But on the edges, when you get to the edges, those atoms either want to really lose one or gain one. They're positive or negative, or they're at least affinity for that, okay? So let's talk about, somebody said gold. Who said gold? Why don't we use gold in our wires? It's really a great conductor.
Because it's really expensive.
It's really rare. It's expensive. The girls have it all tied up in their jewelry, so, I mean, we don't have much left. So, yeah, there's not much of it, except we use it in computers a lot. Why?
Less resistance.
Well, it is, but so is silver, so is copper. Why do we use gold? You know, we got those chips with 1 million transistors on them, and they got all those little tiny connections. Why do we use gold? What's the one thing that women, girls, really like about gold in their jewelry?
It's expensive.
It's expensive. That's true. No. Do they ever have to polish it? Why?
Luster. Yeah.
It doesn't oxidize. Never oxidizes. Gold never oxidizes. So if you have a chip that has 100 connections and you put it in a circuit and it doesn't have gold connections, you can bet that 1 or 2 of those connections are going to oxidize just enough so that they don't work. So you plate them with gold, and then they don't oxidize. And there are actually people out there that collect computers and try to get gold out of them. The old ones used to be the PDPs. They were like the size of this room, and they had lots of gold in them, and it wasn't just plated. So you get a lot of gold out of those. So, but the newer ones are plated pretty thin, a couple of molecules thick. So it's pretty hard to get much gold out of them. But gold's worth a lot of money per ounce, so, you know. So gold, it's a great conductor, but there's not much of it. Doesn't oxidize, but expensive to put into your machine. So if you're going to do a satellite, you want lots of gold because you can fix the satellite once it's up there. Maybe someday, we're getting close. Wouldn't it be cool to be a technician and have a little spacecraft and they go, you know, the D5 Netflix satellite's giving a little trouble, and you go, oh, no problem, up there and fix it, and wouldn't that be cool? I think it'd be great. It's going to happen someday. I guarantee it's going to happen. So we put them in satellites. We put it in computers that we really, and in computers that we buy. Normally just old computers, new computers. The one sitting right behind you's got gold in it. So, and there's the board's actually in the box over there. Silver. We use silver in a lot of things, but it does oxidize, so we have to be careful. Not as much of it either. One of the places that we use a lot of silver is in the wiring of aircraft. It's pretty important that the wires are good in an airplane. So you never see harnesses from aircraft in the scrapyard because all the guys that scrap them know there's silver in that wire and it's worth more. So when they strip all that out, they don't just throw it in the pile with all the rest of the wire out of the cars and whatever. And you can tell, I don't know if you've ever worked with aircraft wire, but it solders really nicely because it's got silver in it. So it takes solder very nicely. So you can solder it in, or usually crimp them and then solder them, you know, so that they're solid. Okay. But it does corrode. If you leave it, it'll corrode. It takes a little while, but it will corrode. But we don't use that in our house wiring because we really don't need to. We get a bad connection in house wiring, we can track it down and fix it. So we use a lot of copper, don't we? Okay. Copper's very readily available. You can buy it all over. There's lots of it in the world. Okay. It's a great conductor. It's not as good as gold or silver, but it is a great conductor. Now, another really great conductor is aluminum. And we used to use aluminum in our houses and our trailer houses. Can you tell me why we don't now?
Fire code?
Well, yeah, that would be where it ends up, but aluminum has a problem.
Is it expansion?
Oxidation.
Yeah, that's why you gotta put the stuff on it.
Gotta put the lube on it, don't you? If you don't, what happens?
It oxidizes over and it's gonna lose connection.
And then it heats up, and you got a fire. They used to put it in trailer houses. Pretty much burned them all down now, because about 20, 30 years ago, they were burning up left and right. Because you came out with those little outlets where you just plug the wire in the back instead of the screw. They just plug all those wires in the back. Trailer house gets old, all the connections start to oxidize, and somebody says, I'm really cold. They plug in an electric heater, and a whole bunch of current goes through there, and it heats up, and it causes a fire, and a trailer house burns down in about 12 minutes. So we usually didn't get there before it was just a frame. So, you know, it was getting to a frame really fast, okay? Houses, they actually did houses too. And those are pretty much all gone too. It's aluminum corrodes. Now we still do it on the services, which to me is really crazy because I built a house and I wanted to put copper in and it doesn't meet code. The state inspector came and told me that. He says, you can't put copper in. It doesn't meet code. I won't pass it. I went, really? Copper? Anyway, so I had to put aluminum in. I had to lube it all up. So it didn't oxidize and burn my house down. So aluminum is a good conductor and it's useful in some areas, and it can be treated so it doesn't oxidize as much, but you have to grease it to the outside environment, or the air will cause it to deteriorate in a hurry. Okay? So all of these metals, and we could talk about chemical elements and other things, have one thing in common. They're either looking for electrons or they're losing electrons. So if we're talking about copper, the outer, and we're just going to talk about normal. We're not going to talk about any, if you start talking about what I don't want to say. I'm not going to go there. If you're just talking about normal bonding, okay, you're talking about orbitals. The last orbital is the one you're looking at that will lose that electron, and it either wants to lose it or gain it. And in copper, it's okay with losing its electron and gaining one from some previous atom. So if I have a piece of wire and I take an electron and I push it in over here, all the electrons just bump through the wire and one falls out on the other end. That's a little more complex than that. But anyway, so that's pretty much what we're looking at. We want to be able to control that because we know we can just push some in and they come out. But it would be nice if we could control how those electrons move. Are they moving or not moving? Are they moving in jumps? What are we going to do here? We're going to control them.